Good morning, my students. We are going to study physics, year 9, about electricity. We have two different methods to connect group of resistors or group of batteries. Why appliances or components in-house are connected in parallel, not in series? This is a question we need to know the meaning of it. When we connect group of resistors in series, we connect them as in the following. This resistance, this another resistance. The first is called R1, the second R2, the third R3. When electric current passes through it, the current moves through the circuit in a straight line. When we put a meter in this position, and in this position, and in this position, and in this position, we observe that the reading of voltmeter doesn't change. This means that I is constant. I is constant in series connection. But when one of them is cuts off or damaged, current does not flow through the circuit. This is the characteristics of connection of series. In series, voltage division, when we connect moving coil galvanometer V1 between the terminals of the first resistor and voltmeter V2 between the terminals of the second, and voltmeter V3 between the terminals of the third, and another voltmeter between the first point and the second point to measure the total potential difference. We observe that the reading of the first is 1 volt, the second 2 volt, the third 3 volt, and the total is 6 volt. This means that V total equal V1 plus V2 plus V3, or the voltage is divided. The voltage of the source is divided among appliances. Switching can be switched on or off together. When one of them is cut off, all the circuits does not move current. One appliance fails, the rest stops operating. Example, 2 lamps, and this is a switch, and this is a source of electricity. Source of electricity is called the battery, is DC current. This current is called DC current. Current flow in this direction according to conventional current. Lamps have equal brightness, but they are dim. Batteries run out slowly. If one lamp flows, the whole circuit breaks, and the other lamps go out too. When it is connected in parallel, this is disadvantages of the connection in series, but we use it in another states. When we connect them in parallel, the advantages of connection in parallel, we connect 2 or more lamps as in the figure. The positive, negative, and the positive pole of the battery connected with the 2 points and connected with the 2 points. This lamp is parallel to the second, and this lamp connected parallel to the battery. When we use voltmeter to measure the potential difference between this point and another voltmeter between 2 points, we observe that the reading of voltmeter is constant. the reading of voltmeter is constant means voltage does not divide in connection in parallel, but the current in this case current is divided while the voltage is constant. The voltage is constant. Each appliance receives the same voltage. This means that gives maximum power. Can be used as a switch on or switch off independently. If one appliance falls, the rest operate normally. If this lamp cuts off, the other lamp will glow, flashes. Lamps equal brightness. They are fully bright. Battery runs out quickly. If one lamp blows, only branch breaks, the other lamp will continue working. If you have an example for connection of parallel and series. Example, if an identical lamp is added in parallel, this is the battery, produce current of 2 ampere. This is a meter device or an instrument used to measure the current intensity. At this point, current is divided into 1 ampere and another part 1 ampere in the second side. So a meter, reading of a meter is 1 ampere. The reading of a meter is 1 ampere because the total current is 2 ampere. If identical lamps are added in series like this, or one connected in series, in this case, a total equivalent resistance is halved. Because R equivalent in case of parallel equal R divided N. N it is the number of resistors. In this case, we have 2 resistors, or R divided 2. The equivalent resistance is halved because we have 2 resistors. If you have 3 resistors, the equivalent resistance equal R over 3. The current intensity is inversely proportional with the resistance. The current supplied by battery is doubled. Current is doubled. Increases because resistance decreases. Resistance decreases to its half value, the current is doubled, increases to double. Current in each branch stay the same, doesn't change. If you have a battery, produces current 1 ampere passing through the ammeter. 1 ampere reach to the lamp of resistance 2 ohm. If another battery produces current half ampere, the ammeter measures the value of the current intensity half ampere passes through 2 resistors connected in series. This resistance 2 ohm, the equivalent resistance for the 2 resistors equal 4 ohm. The resistance 2 ohm, the resistance becomes 4 ohm, the resistance is doubled. When the resistance is doubled, the current intensity, inversely, current intensity 1, it becomes half. The current intensity decreases to its half value when the resistance is doubled. Total resistance is doubled. The current supplied by the battery is halved. Current is halved each lamp. Current halved each lamp. Now we are going to study another example. Lamp is connected in 4 circuits. This is the lamp connected with the 4 circuits. This is the first circuit, second circuit, third circuit, fourth circuit. With identical resistors, this resistance is R, R, any resistance equal R, any resistance equal R. Arrange the circuit by the order descending brightness. Order descending brightness. The solution. Most brightness, the lowest brightness to least brightness generates energy. Greatest resistance. Greatest resistance. The resistance of this circuit is 2R. This resistance equivalent to R over 2 divided 2. This resistance half R plus R equal 1.5 R. 1.5 R. This R. This means that the resistance C has R over 2. R over 2. The resistance AR 1.5. R over 2 is the smallest resistance. Smallest resistance gives brightness, more brightness. This is the first, which gives more flash or more light. The second is A. The second is A because the resistance in the first, in the circuit C is R over 2, while in A equal R. Number 3, B, contains the resistance 1.5 R. D contains 2 R. This is the relation between the brightness and the current intensity and the electric resistance. Example 3. Example 3. When all the switches are closed, all lamps are lit. Which switch if open? Switch, this is the source of electric current. This is switch B, switch A, switch C, switch D. Makes only one lamp goes out when we close them. For only lamp go out, switch C. Why? Switch C. When we closed all lamps, this is closed, this is closed, this is closed. The current path through this circuit. Make 2 lamps go out. Make 2 lamps go out. 2 lamps go out, switch D. When we open this, 2 lamps go out because there is no current flow through them. Makes all lamps go out. Switch A and B. A connected with the source, so there is no current pass through it. B connected with it, which current flow, and at this point, which is called node divided, there is no current. There is no current divided. This means that the lamps are go out. The last example, find the current in resistance 3 ohm. This is the potential difference, which is called 24 volt. The first resistance 4 ohm, 3 ohm, 5 ohm. And the voltage across 4 ohm, we need to determine the current intensity I, which passing through 3 ohm, and voltage through 4 ohm. Combined in series resistance, total resistance are equivalent equal R1 plus R2 plus R3 equal 4 plus 3 plus 5 equal 12 ohm. This is the total resistance. Current intensity equal EMF or voltage divided R total. Voltage 24 divided 12 equal 2 ampere. This means that the current intensity passing through it 2 ampere. The voltage V equal IR. I equal 2 ampere through the resistance of 4 يبقى times 4 equal 8 voltage. These some examples about connection of series and in parallel. Goodbye and good luck, my students.